let's go back to the Mars Climate Orbiter, where it never got into orbit because the scientists were using metric and you engineers were still on imperial units. What's up with that?
What's up with that is we've carried mixed units in the United States for way too long.
Be blaming the country. All right, blame it. You're the engineering people. You know you're talking to scientists.
Did that scenario cause them to make the change? Or are they still being dumbasses?
I think, Chuck, there's still pockets of dumbassery going on.
This is StarTalk. Neil deGrasse Tyson, you're a personal astrophysicist. I got Chuck Nice with me. Chuck, baby, how you doing?
Hey, Neil, what's happening?
All right. We got a good show today. Oh, my gosh.
What's on tap?
The future of the space industry.
Oh, and you say that's a good show?
Oh, yeah. Oh, yeah.
You think there's a good future for the space industry?
You want to get off this earth? You better think it's good.
Okay. Well, you know, I do want to get off this earth. I'm just afraid of who might be driving.
Oh, there you go. There you go. Did I tell you? People say, you want to go in the space? You want to go in this guy's rocket and
right.
Bezos' rocket? I said, yeah, but I want him to fly his mother first.
Nice.
Bring her back. And
nice.
then I'm cool.
Right, then I'm cool.
Then maybe I'll step on the ship. So I love this field.
Okay.
But I have no specific engineering expertise.
All right.
So we combed the land.
Yes.
To find somebody who's been in and out, and in that whole field.
Oh, right on.
And we got a man right here.
Yes.
Right here, sitting right here. Sir.
Neil.
Welcome to StarTalk. Jeff, did I pronounce your last name correctly? Thornburg.
That's correct.
There you go, Jeff Thornburg.
Oh, there was a very popular, nighttime soap opera called The Thornburgs.
Thornbirds.
Oh.
Yes.
Well,
slightly off.
As you can tell, I was a huge fan of the show.
You would be surprised, Chuck, how many kids in school equated Thornbirds with Thornburg. So you're in great company. You're in great company.
You should be embarrassed that you corrected someone on a soap opera name. What else do you do? Is that what you're doing during the daytime when you should be building rockets?
Well, everybody has a side hustle.
Very good.
So you are currently CEO of Portal Space Systems.
Yes, sir.
I love that.
That's very
Aerospace engineer.
Nice.
We need more of those.
Yeah.
And you have a background with the Air Force. That might have been the Space Force if it had been now. NASA Aerojet.
Yes.
Love Aerojet.
Wow.
SpaceX and more. So you've been around.
I've been around.
But it sounds like you can't hold down a job.
Yeah, well.
What's the difference between everyone wanting you and everyone firing you?
He's like, don't shame my success with this drinking problem.
What's the difference?
Look at the success I have achieved, all while holding down the drinking problem.
My best answer to that, Neil, is I grew up like I think you and others did, and aspired for this science fiction world that we all would like to see. And I would go work at these places and be like, not moving fast enough, not moving fast enough, not moving fast enough.
Very cool.
And so,
and then you decided to take it in your own hands.
Yes, sir.
Nice.
Ooh. That's audacious.
I love that.
No, that's bodacious.
I have a very loving wife who has been very patient with my 30-year career.
That's definitely, you need one of those in that situation.
Yeah, I need one of those.
Tell me what is Portal Space Systems and why that's different from what you've seen before.
Portal is building the most rapidly maneuverable spacecraft that's ever been built. And that's important because we're doing it with a lot of payload flexibility. So what that means is we can accomplish a lot of missions for defense and commercial customers. We can do it with speed. The problem with movement on space is you can't get anywhere very fast right now, especially with satellites and defense systems. So I got frustrated and I said, this is a solvable engineering problem. Why aren't we doing more about it? Okay, if no one's going to do anything about it, I'm going to go do something about it.
And engineers just love problems.
They do. They do. And they love developing new types of spacecraft.
So when you say get somewhere faster, you want to get to 9 months is not fast enough for you to get to Mars.
No, absolutely not.
Okay.
Look at that.
So I think my long-term vision is nuclear thermal propulsion, I think, is a key thing in my lifetime.
As would be, that's anyone.
Sure.
You dreamt that last
Are
night.
you kidding me? That's how I came in this world. My first words after they slapped me on my ass was, when are we getting to nuclear thermal propulsion?
Thank you, Chuck. Exactly. That's what I've been saying for years now.
Wait, so you're talking about how nimble can you be in the 3D space environment?
Yeah, so our current spacecraft platform can move from mid-Earth orbit to low Earth orbit in less than 3 hours. It can move from mid-Earth orbit to GEO in less than a day. It can go from low Earth orbit to geostationary orbit in a day. So those types of time.
That's not fast enough for you?
That is fast enough for me.
Good.
It's just not possible with frequency now, unless you're using a rocket to do it.
It's not a routine thing.
It's not a routine thing.
Right. Okay. So you're like, I'm going to turn commercial space into trucking.
Could you have more romantic terms than that?
No, but because that's like very understandable.
He's going to be the Amazon of delivery system of space?
Yeah, no,
Or the
because like
FedEx. Yeah.
FedEx?
At one point, once we had containers coming in and container shipping, like the trucking industry boomed because somebody had to figure out a way to get these containers where they had to go, and quickly. And so, like, you're doing that, which is
our customers don't care about how cool the tech is.
Right.
They just want
speed.
They want it now. If there's something going on in the world they need to be looking after, they want to do it now. If they've got a spacecraft in trouble, they want to see it now. They don't want to agonize over, well, if I move it, maybe I'll never get to move this spacecraft again because it doesn't have enough.
I didn't even know that was a problem until you just said it right now. And let me not even think of it as a problem. Let me think of it as an unrealized need that you are fulfilling. Very nice.
That's right.
So we'll get back to that, but tell me, because you had your whole life is in this, and we're probably about the same age, so I'm feeling your enthusiasm and your disappointments with what we've seen out there.
My long lost brother in space. Yes, I'm feeling that.
So what are some things that you have worked on that you could tell us about?
One of the most exciting projects I got was when I was a young engineer with the Air Force Research Lab, and I got to develop a brand new type of rocket engine called a full flow stage combustion engine. That's a fancy name for saying the highest performing rocket engine ever made.
And just to be clear, Air Force Research Lab, that's not just another lab on the street corner. That's an FFRDC, if I remember correctly, or not?
It's a government lab.
Okay.
There are contractors like aerospace that support in an FFRDC way.
What does that mean, please? FFRDC.
Federal funded.
Stay with us, Chuck.
Yeah. Trying to keep up here, but you guys are like rocketing off.
Federally funded research and development operation.
Okay.
Where it's a way for the government to get a piece of a pie that's being baked that corporations wouldn't otherwise do because it's a little risky. It's a little kind of off the thing, but
No business case, no profit margin.
Yeah.
I'm doing that now with NVIDIA.
okay.
Right. So I got to work on that rocket engine program, and it formed a kernel of several kernels of technology that seeded the propulsion industry for years to come. So I got to work on that program between 1999 and 2004, and then that seeded engine programs like J2X that were part of the Ares rocket program. It seeded things like what Stoke is doing with their full flow engine. It seeded what I did with Raptor later on at SpaceX, because I developed and architected the Raptor engine system for Starship. So
when SpaceX rose up out of the din of rocket corporations, were you cherry-picked? Did they cherry-pick you from your previous location?
I don't know that I ever got the full story, but this is a true story, is that Elon called me at home in Huntsville and said, I got a project I think you might be interested in.
So that counts as being cherry-picked, I
think so.
Yeah, when the guy who owns the thing calls you personally, he's stealing you.
So shortly after I left NASA in Huntsville and went to SpaceX.
It's Huntsville, Alabama.
Alabama.
And of course, we just learned that the headquarters for the Space Force is moving from Colorado Springs to Huntsville, Alabama. It was a little weird because the president said, and from now on will be named Rocket City, but it's always called Rocket City.
Yeah,
It's always been Rocket City.
It's always been Rocket
he
City.
does that. Let me ask you both this then before I know, because you brought up these FFRDC.
Yeah.
Is that still necessary now that there's so much commercial activity in space travel? Is it still necessary for the government to seed money into things so that we can then go forward in discovery?
I love your question because what I've been watching happening in the quote new space industry is venture capital and businesses chase things that add value or add to the stock price or add to profit. The government and the FFRDCs focus on necessary technology that there's no business case for. So
no business case at the time they're funding it.
Okay.
Who knows what'll happen after?
So I feel that FFRDC should definitely be seeding new technologies like the ones we're developing at Portal for this rapid movement because no one else is going to do it. So NASA and the Air Force have done a great job over the years of developing technology that then they later put next to the Ark of the Covenant in the warehouse at the end of Raiders of the Lost Ark. And I've been fortunate enough on a few different occasions to go back into the warehouse and pull some of these things that the government has developed.
It's so beautiful.
Yeah.
That's excellent.
So, yes, I think the need is definitely there. And when
your face didn't melt when
my
you
face didn't melt,
reopened the Ark.
But when I was in the Air Force specifically, one of the biggest issues is that nobody has that foresight to know all of the ways the technology will be applied.
Right.
And that's why
Nobody has that.
Right. That's why it's so important to keep the government involved in pushing that boundary. And I think that's where the government should be spending their money. Unfortunately, those government budgets are shrinking because I think some people think, well, private industry is just going to do it, so why do we have to fund it anymore? But what they don't understand is VCs and private industry are chasing value creation and stock price and profit, and that may not be in the same wheelhouse as the technologies we need to actually get humans to Mars, to get humans to the moon, and to explore the solar system.
Yeah.
And that's where China enters the picture.
Then there was China.
And then there was China.
So tell me about Aerojet. What'd you do there?
I worked as an engineering manager and director on liquid rocket engine technology development, did a lot of turbo pump development for liquid rocket engines while I was there.
I mean, we've had liquid fuel forever. I mean, since Goddard, right? So what new thing was necessary?
Getting weight out of the system.
Oh, every ounce matters.
Every ounce matters. And combining components, bringing in technologies like additive manufacturing to reduce part count.
Wow.
And figure out how to qualify systems to do that.
If you reduce part count,
yes,
that reduces the error, the points of failure.
Correct.
That could take place.
Reliability goes up as part count goes down.
Because I remember when the shuttle first came out. Okay.
Yeah.
And there was this headline that sounded like it was bragging. And I said, that's not a brag. It said, the space shuttle, it's the most complex rocket ever to be launched. And it's like, you don't want that.
Yeah, right.
But am I right? I mean, you're the
correct.
engineer.
Yes.
It's like, don't tell me that.
Well, in fact, they couldn't reuse it the way they wanted to because of that fact. You know, shuttles were going to launch 25 times.
Yeah, every couple of weeks.
Every couple of weeks. And then they're like, oh, these engines aren't as easy to refurbish as we thought. We've actually have to rebuild them after every flight. Oh, we got wiring issues that we hadn't accounted for. Oh, we've got tiles.
Tiles, right, that'll fall off.
Right.
So when the shuttle was retired, we didn't have a way to get to space.
Yes.
And so I guess we used with Russia. I mean, they were our friends back then. Who knows what they are today? But they had the Soyuz capsule. Does the Soyuz capsule have like 10 parts to it or something? It's kind of a blunt instrument that works every single time. Tell me about the Soyuz.
Well, the Russian...
And you testified about that. So catch me up on that.
I mean, the Russian development of rocket technology is interesting because you have to go all the way back to the end of World War II. We cherry-picked rocket scientists. The U.S. grabbed their lot, including von Braun.
Werner von Braun, yeah.
Russians grabbed their lot. And what happened was the Russian lot of German rocket scientists really ended up focusing on reliability and part count and manufacturability. Von Braun and his team, and what later became the bulk of NASA, focused on performance and perfection. And so there was two completely different thought processes between Russian rocketry and American rocketry at that point that can trace themselves all the way back to the end of the Cold War.
And that persisted. And so to this day, the Soyuz, isn't it the most reliable
It is, and it has had heritage dating all the way back to the 50s because they've never changed it. And there's
So it's still got a compass. Or in the Flintstones, you look at their legs are running underneath the
and I mean, and their technology, there was so much elegance in their manufacturing that we ended up buying a lot of their engines at the end of the Cold War because we didn't want the Russian rocket scientists going to Iran and North Korea and other places.
That was part of our relationship with the space station to bring them on, give them something to do. In the day, everything that NASA launched said NASA on it, even if it was built by Boeing or Lockheed Martin or whoever else. But private enterprise is now putting things on the shelf that NASA then selects off the shelf, and that all has the name of the companies on it.
Yes.
So this is a shift. Could you take us through that shift?
Sure.
From the old days into what's actually happening now?
Yeah. So about the time, the early 2000s is when Blue Origin and SpaceX were incorporated. And then over the next 10 years, they started to develop capabilities to launch things that were interesting to NASA. When I was at SpaceX, and we were developing Falcon 9, they didn't believe that we could do those things at those price points. So they kind of patted us on the head and said, that's cute, let us know when it works. And then it did work. And then that's when the real interest came forward, because now for $60 million a launch, you could do a lot of cool things that you couldn't do with the Space Shuttle program. And then the race was on.
Space Shuttle was $1 billion a launch or something.
Something
it
like
turned out huge.
Moly.
Yeah, part of it was because there weren't as many launches in a year to amortize the cost of the marching army to keep all that going. And with more launches, then the less per launch the effective cost is. But if you bring the cost down to that, that's another ball game.
It's a whole other ball game. And that's what got us excited about the shuttle retiring, because the race was on to get Dragon on a Falcon 9 as fast as possible and get astronauts to the station and get American astronauts again to orbit. And we put all the NASA logos and everything, and they were a great partner and all that. But, it was weird because people would come up to us and say, does NASA exist anymore? Because SpaceX seems to be launching everything.
So let's get the animal straight here. So the Dragon is the capsule.
Correct.
The Falcon 9 or the Falcon Heavy. The Falcon is the rocket, the launch system.
First and second stages
of the system. Good. Just get the animal. If you were,
yes.
Were you up with the animals there?
Yeah. We didn't we go to SpaceX and I think you said it's the number of.
Well, it looked like it. Is it true? The Falcon 9 has 9 engines on the bottom.
That's correct.
Okay, because we visited the headquarters and
nice.
Yeah, it was one. We had StarTalk goes to SpaceX.
Yes,
I think it's online.
Yes,
and we were just chilling and looking at the rocket, and it's the one that it's the first stage that comes back.
Correct.
Right, and you see it with the tripod.
Yep,
a big one mounted outside.
And we had to put that engine in the center to help facilitate the landing burn.
Right. Let me ask you that. Let me ask you, if you're going to bring the stage back, that means you are using weight for fuel to guide the thing back for a soft landing. But I want that weight for my payload. So where do you, as an engineer, where do those two lines cross?
So the elegance in the engineering is that Falcon 9, basically, we actually pushed that vehicle to its absolute limit before anybody ever saw it do its thing. And we did that because we didn't want any excess fuel on that vehicle when it landed back. So then what we did, the company did, the business people did, is they said, look, we're going to sell you an expendable stage or a reusable stage. And if you do the reusable, you'll save some money.
Oh, so then the buyer makes that decision.
That's right. Then the market.
That's brilliant.
The market chooses.
Brilliant.
What did the market choose? They chose the reusable version because it made the most financial sense.
Wow.
But so there's two things. There's a business model.
I'm glad to hear that. That puts a lot in context for me.
Right. As an engineer, I have to make that system as efficient as possible, meaning there should be no unused fuel when it lands, and then let the buyer and the market choose that configuration because it makes the most financial sense, and then everybody wins.
Occasionally, you need the payload, which, if memory serves, they needed that extra weight for the Europa Clipper mission. I think the first stage did not return smoothly.
I think that
got dropped into the ocean. They needed that.
You got to have all the Delta V available to go to Europa.
Okay.
So, yeah.
Yeah, Europa is the Jupiter's moon.
Right.
Yeah, the Europa Clipper will loop around,
Yes.
make radar measurements beneath
And
the
they'll
ice.
sell that. But I think the business case people should understand is if you buy an expendable version, now that hardware can never be used again. And there's value associated with that hardware. So you're going to pay to basically use it all in one shot. And so that's another way to drive market value. That's a good business case as well.
So at the risk of asking the obvious, all these places you've worked, presumably there's a lot of wisdom you have gleaned from that you bring to your current job. Is that a fair statement?
I've seen a lot. Yes, I think that's a fair statement. That's definitely true. But I think
You've seen the mountaintop.
I think more importantly, though, is I got to work with these graybeards at NASA and the Air Force. I got to work with some great people in industry.
Did you say gray beards?
Graybeards, yes.
Do they have beards in the Air Force? I thought they make you shave.
Yeah, well, the civil servants have beards.
Okay. That's a pretty lax military if they've been walking around with a beard.
So I tried to be a very good student of those older folks that had seen a lot more things than I had in my career. So
give us a minute. We don't always have engineers on the show. It's mostly scientists. And for what it's worth, anytime people say to me, oh, you guys are doing great things in space, I say, look, we know what we want to do, but we don't know how to build the stuff. There are engineers who you never come interview who enabled the James Webb Space Telescope, who enabled the Hubble telescope. And so I just want to, on record, give a shout out to nameless engineers who
are
make the
responsible
scientists
for the success of everything.
Of everything, and make the scientists look good, but you only see the scientists get interviewed because they're talking about the results of the experiment.
right.
And whereas the engineer is not in that loop. So
I think that's awesome that you're doing that. And two, that's the best part of my job is like, I know engineers that got degrees that never really became engineers because they never got to actually experience an idea that you actually have to go build and it needs to work. And then I work with people every day, some of which that don't understand that engineering is sometimes an art form because you don't know all the things. You have to design around the uncertainty. Like if you came to me with a new spacecraft system, I'd say, yeah, that's theoretically possible. Now let's go see what we can actually build and how accurate I could build it.
like a warp drive.
Right.
We could totally work on that, Neil.
Yeah, what are you doing here? Get back to work on that.
That's
so
funny.
So
you guys are like the workman that comes in your home, the contractor, and he's like, yeah, we're not going to know anything until we open up these walls.
I do have.
Yeah. Gotta tell you, could be a lot of problems back there. I mean, this could be a $200 job or it could be a $20,000 job. We don't know.
That sounds just like my engineers when I'm pricing a program out. So you're hitting it right on the head.
So I just want to highlight for our audience, which is primarily a science-leaning audience rather than engineering-leaning, tell me the value of failure. Let's just start there.
I'll answer that with a quick story, which is a lot of legacy government and NASA programs have this failure is not an option moniker to them. And what that means is to have infinitely low risk requires infinitely high cost. And so that's not how a lot of commercial startups and businesses have formed in the last decade or so, because instead there's a different approach in engineering where we want to actually break it because we want to see where the design fails and what we don't know yet and what we need to fix. And I think a lot of the legacy NASA programs have suffered at times because they've had to try to get everything right on the first go. And that's a pretty tall order. That's why these aerospace programs have taken so much longer than anybody ever wanted from a schedule-wise or from a cost standpoint. So I think
Elon in the early days was very visible with his rocket failures.
Yes.
And he made a very important point at every turn. We're going to learn something from this. Although it sounded a little too euphemistic at times, where the rocket blows up and it's, no, that was not a failure. That was an experiment rich in data.
and it's true to a certain extent, but not all failures are planned, and most of them aren't. And but the value is if your company or organizational culture accepts failure, then you will actually get to the end product much faster.
There it is right there. That's it.
But also it's kind of a public perception problem for NASA because there's never been a movie made about SpaceX or Elon Musk, but the whole idea behind the whole Apollo missions and everything that NASA does is triumph. We did it. And then the one time something goes wrong, it's global headlines of how badly they failed and what an incredible tragedy it is.
Right.
If NASA blew up 100 rockets, there'd be no more tax dollars going to NASA, whereas Elon Musk can blow up as many rockets as he wants.
Yeah, but as Neil knows as well, look at the history of the Mercury, Gemini, Apollo program. We blew up a ton of stuff.
Yeah.
Those young men and women were in their 20s. They looked like SpaceX looked a few years ago.
Wow.
And so NASA used to operate exactly in that mold, but somewhere along the way, politics took over and it got different for them. So I think NASA should focus on the programs that aren't viable as a business, that are pushing technology forward, because I think that's what they do really well at. I don't think they do well in big rocket programs. I mean, just
this is my reply. I'm asked it often, as you can imagine. We said it earlier. With private enterprise coming in, why do we need NASA? Because there are things that private enterprise would never engage on the frontier, where there's either risk that they would not take or return on investment that does
That
not
they will
exist.
not make.
Right, exactly.
And I don't think nation states should rely on CEOs to be their only hope in achieving certain national goals. I just think that's a bad idea.
Yeah, I wonder where I kind of agree.
Could be wrong,
I agree with you
but I mean,
there.
that's just one person's opinion.
Yeah, when a leader of a nation breaks up with a CEO, like it can get ugly. You know what I mean? Like who gets the cat?
So you want people to be more comfortable with failure because that's how you proceed. Not failure from blunder, but failure from something you had not seen coming. It's a different kind of failure, right?
I think people think engineers just know, and therefore when we fail, we're stupid or we're a bad engineer. And they don't understand the art of engineering is designing a system around unknowns, and that we don't always know the first time it's going to be successful. So I think
which would include the unknown unknowns.
Correct. Mm-hmm. I think that's the unlock for people to know failure is a good thing, because you've now given engineers a gift, because now they have all of the information. So that's why failure is so important to engineering, because now you've pushed the design all the way up to the line. You don't have to guess about it anymore. So now you've gone from that initial phase of engineering around the margins you don't know, which normally means it's heavier or carries more fuel or less efficient in some way because you're just trying to get it to work. And when you fail it, now you can totally isolate that to what it needs to be. And that's why things like the Falcon 9 first stage land the way they do. Because we failed so many of those, as the gag reel has shown over the years.
Yeah, back when you were at SpaceX. Yeah.
I'm gonna start looking at my life differently. I'm just an engineer.
All the failures.
Who knew?
Let me take you somewhere, because this comes up and I want to hear it. I've spoken of it as a scientist, but I want to hear an engineer speak of this. Let's say there's some disaster, NASA disaster, okay? Always somebody digs up an engineer's memo that said you shouldn't launch because this might fail. And then others say, why didn't you pay attention to that? And nobody looks to all the successful launches to dig up the very same letters that say you shouldn't launch because that's going to fail, and it doesn't fail. So how do you square how NASA or any company should respond to the claims that you didn't heed advice, when presumably, I'm thinking, there are memos like that every single launch?
So there's a failure in leadership there that I personally believe in, that I operate differently in my organizations over the years and my company now. You're always going to have somebody say, I'm worried about this before you launch or before you field a spacecraft on orbit. And so what I do is we have what's called active risk management, which is a NASA term. But we look at all those risks before we fly. At every organization, there needs to be a person that signs off on the final risk posture for whatever mission you're flying. And that person, it's okay for them to take risk, but they need to document why they're taking that risk and why it's acceptable. So when I build flight hardware, we do a final risk review before it flies. We look at all of the key risks. And if people feel really strongly that they're worried about something, then I say, I'm taking that risk away from you. You don't have to stress about that anymore. I'm going to say it's okay, and I'm going to justify it because of this.
Okay, so now something goes bad. Now the press comes and they see that memo. And
Right.
they say, why didn't you heed the advice of that memo?
And I had already addressed that in the documentation that said, I thought this was an acceptable risk because of X, Y, and Z. And I know I have to stand by that, whether it fails or not.
Okay, so now they put you in front of the bereaved relatives.
Now you're standing on a jet and the door has blown off mid-flight. How do you get around it?
Well, but that's
That could never happen.
I think there's incompetence and there's acceptable risk documentation. I guess that's what I was getting
That's
at.
what
is-
you're saying.
That's an important distinction.
That's it.
I make it a point to have acceptable risk documentation. So if the worst happens, I can at least explain myself on why I thought that was okay.
Gotcha.
And then I'm also fine saying I was wrong.
It's like a pharmaceutical disclaimer. Side effects may include, and they're highly unlikely, but they list even the most unlikely of side effects. But they say, hey, listen, the chances of this happening are so slim that this is deemed safe. But there's a very, very slim chance that this could happen.
In space, there's never a guarantee. That's the thing.
No such thing as safe in space.
There's no such thing.
It's just the risk that you accept.
I think companies get into trouble when management takes that authority away from engineering and says, we don't care what you guys think, we're doing this anyway.
That's when you got a problem.
That's when you got a problem. And so when you're talking about, door hatches blowing off or submarines failing when they shouldn't have been designed the way they were or whatever, that's a failure in leadership.
Gotcha.
And so I think you're still going to have failures. And I'm just saying, let's avoid the failure
That's
in leadership
interesting.
piece of that.
Not enough attention is given to where the leadership matters versus the engineering declarations of what the risk factors are.
That's right.
Yeah.
Because people just want to get to the end.
Okay,
they
so
get
how
a lot of
about,
free-
just since we're here, the Hubble telescope, the mirror has a perfect shape. The secondary mirror has a perfect shape, but they don't play in the sandbox together, and they were not tested together. So is that leadership?
That's a failure in system engineering, in my opinion, because you didn't have an adequate test program.
How big was system engineering as a thing at the time? We're talking about
We're
the
talking
late
about
80s.
NASA. This is system engineering haven.
That's what it is. You're right.
So, of
But I
all
don't think system engineering was taught in schools as a branch of engineering until later than it should have.
Well,
am I right there?
I mean, I've seen evidence in the shuttle program that they had very robust system engineering back in that time frame.
okay,
So,
in the 80s. then,
maybe
the
NASA
90s,
didn't
yeah.
equivalently apply it all over the different centers and
Gotcha.
programs, but there is no better place for systems engineering execution than NASA.
So that's a blunder. Somebody,
It's a failure of imagination to be like, should we test these systems before they fly? Maybe.
Wow.
all right, one more. Let's go back to the Mars climate orbiter, where it never got into orbit because the scientists were using metric and you engineers were still on imperial units of force.
I remember you telling me that
What's
story.
up with that?
That's
That's such a
hilarious.
classic story and true. What's up with that is we've carried mixed units in the United States for way too
Be
long.
blaming the country. All right, blame it. You're the engineering people. You know you're talking to scientists. You know.
Well,
You want the scientists to be using pounds and ounces?
I'm not going to make
We're not.
I'm not going to make excuses.
That's
for the
right. You better
engineers.
not.
But I will tell you why it's happened, in my opinion.
Okay.
A lot of the engineering tools for spacecraft and launch vehicles were all written in imperial units. And so they've been very slow, the community at large, to change those tools to a metric standard.
Okay.
And so engineers get lazy because they want to stay in the units they're comfortable with.
Well, did that scenario cause them to make the change, or are they still doing the same
They're still
thing?
being dumbass.
I think there's
That's
still...
your word. You say it.
Are they still being dumbasses?
I think, Chuck, there's still pockets of dumbassery going on.
Oh, that's a Chuckism right there.
There we go. It's fantastic.
The dumbassitude of the system
That's
just
right.
doesn't. So we've seen in recent months a move to cut costs at NASA. Cut costs in many ways, including the science budget, I think got the biggest cut. And there's some attrition, people leaving and not being replaced, early retirement. And so it seems like we're losing some legacy wisdom with that shift. Could you reflect on what you think might be the future consequences of this?
Absolutely. What comes to my mind, there's two things that I actually worry about now, which is we're watching our scientists walk over to other countries because there's no funding for them here.
I have two colleagues, not in astrophysics, but in other physical sciences. They said they got a phone call from France.
Yeah.
They say,
hello. What are you doing right now? I hear you are being fired. Perhaps you would like to come to France
so
and make a baguette rocket.
the baguette rocket.
Be tasty.
That would be funny. A rocket in the shape of a baguette. Dude.
But like, so you've got the scientists vacating, and then you've got NASA engineers and folks that will not be doing the fundamental research. We've been robbing R&D from the United States for, my career has spanned 30 years at this point. I can't talk to all the things that happened before me, but I can talk to all the things that happened in 30 years in my experience. And it was bad when I started my career. It's even worse now 30 years later. I think current events are going to have ramifications for America as a leader in science and technology for decades to come. Absolutely. Because of what's happening now.
We're plundering our own intellectual treasure is what we're doing.
Because you don't know which experiments are going to work.
Right.
You have to fund a lot of different science and technology areas, hoping that 1 out of 10 or 15 are going to be winners.
Why don't they know this?
I don't know. I guess that's why I'm here. Let's get the word out.
You should be on a podcast.
I should think about that.
Let's work on that. Gosh. Speaking as an academic, if I come up with a great idea and I publish it, and then all my colleagues see it, they can judge it, see if there's a flaw, or use it as a stepstone to reach a next goal. That's the openness that is fundamental to the progress of science. You're in a competitive industry. Mm-hmm. If you make some discovery, would you be resistant to patent it because then other people would see it? How does intellectual property work in your business?
There is a strong desire to hide things that are unique because it becomes intellectual property and IP of the business that can actually add to its value.
So tell me things you're hiding now.
So, sure, I'm happy.
No.
Remember that warp engine you talked about?
So one of the things as a CEO of a space startup that I think about a lot is integrity. And so to your kind of what you're scratching out a little bit is if there was something so great that could benefit humanity, I learned a lot from Paul Allen when I worked for him because one of the things I took
Microsoft Paul
Allen. And one of the things I took away from Paul was technology for the benefit of humanity. So that's one of our kind of cultural touchstones at Portal Space Systems. So if we had something so great and so beneficial to humanity, I wouldn't want to hide that. But that's just my take on integrity.
And what does your wife feel about this?
Well, we should talk to her about that. It's probably going to come down to the value and the dollar. I think she'd rather have a husband with integrity than without. It's what I think she'd probably say.
That's a great answer. Yeah.
But we don't have enough integrity in the business right now is a personal observation because the push to make money, the push to grow a business and satisfy investors sometimes compromises people's value systems in ways that aren't great.
So how could that, because it seems to me like what you're doing is either comes down to this works or it doesn't. Mm-hmm. So I'm sure there are people who feel like, well, what do I need integrity for? Because it either works or it doesn't, so what difference does it make? Where exactly does a lack of integrity hurt the business and then subsequently?
I think lying about the progress of your product.
That's where I keep the money coming.
That's where I see it the most.
I see.
Vaporware.
Businesses are trying to drive for that next fundraise, that next investor.
Okay.
And they lie their asses off to get to the next step.
Okay.
And that's where I see it the most.
Vaporware. That's what that is.
I don't know what vaporware
Well, there's
is.
software.
Oh, vaporware.
There's hardware.
Oh.
There's wetware.
Wetware, yeah.
Which is the brain.
Right.
And then there's
That's us.
vaporware.
And vaporware.
It's just vapor.
Yeah,
There's nothing behind the
That
idea.
is my Uncle Jimmy at a cookout. Vaporware. Yes, I didn't have a name for it until now.
So take me back to the billionaire boys space race. I mean, they're billionaires and they had the cash.
Mm-hmm.
How does that work compared with someone who has a brilliant idea and just gets VC money to come in and help them?
Yeah, well, with Elon, he had that money from PayPal to start Tesla and SpaceX. So he had a $100 million head start that most people don't have.
Yeah, VCs will come up with $100 million. You can get that.
I mean, you have to work at it. It doesn't happen that fast.
Okay.
Normally you still end up going through a process where you're going to raise a pre-seed round of a few million and then a seed of maybe 10 or 20 million and then
Plus,
blah,
you
blah,
owe
blah.
the VC at the end, where if Elon is spending his own money, he just owes himself.
You're diluting your business every time you raise money.
Yes.
And Elon didn't have to do that because it was his own
It's
money.
his own money.
To begin with.
So let me ask you, because I'm just fascinated by this whole thing right now. How does a VC know anything about thermonuclear propulsion? I mean, seriously, like, I need $30 million.
This is where he's got to be a salesman.
Yeah. I mean,
So when we started the company 4 years ago, we decided to pursue solar thermal propulsion because it was a stepping stone to get to nuclear propulsion later. But nobody knew what that was or how it could translate into getting you faster movement on orbit. So you're right. The CEO has to be a salesman first, and then you have to start proving that you can build this hardware. And then you start building hardware, you start doing testing, you start showing people.
Plus, you're going to assemble a board of some kind who's looking over your shoulder.
I've started to do that now, with where we are.
He hadn't do that.
he didn't need to.
He hadn't seen him.
Now you made him actually say it publicly.
I have a board, but it's a small board. But
His mom is on the board. You're doing so well, son.
that's a good idea. That's a good idea, Neil. I hadn't thought about that.
That's funny.
No, you need some skeptical physicists on your board to know what's possible and what isn't.
That's true. I can always use good skeptics on the board.
Yeah.
Yeah, but the investors typically don't know anything about the technology, to your question. And they hire people.
And that's not unique to space, right?
No.
Almost all the high-tech frontier companies, VCs just like the idea.
So one of the things we did at Portal was we started working with the Space Force and the Air Force on small business innovative research contracts so that we could show people that knew things about space, that knew the technology, that investors could then get confidence on that we were on the right track of things. So there's just a lot of steps you got to take to try to convince people something's real. And I wanted to do that with data as much as salesmanship, because I didn't want to be vaporware.
Okay.
So could you give us a kind of overview on the history of propulsion and how the ideas have landed, what's working, what has underperformed relative to predictions, what has overperformed? What we do know is that we don't really have flying cars. We have these flying drones, okay? They want to call them flying taxis, but they're helicopter drones, right? So in the old days, there was just simple Goddard liquid propulsion that you can throttle, I guess. It's chemical energy.
Yes,
We're still using chemical energy.
we are.
So what's up with that?
Well, to get out of Earth's gravity well, you want a lot of thrust, and liquid rocket engines are still the best way to get off the ground and into orbit. Where technology has now started to evolve is once you're in orbit, now what do you do? I would argue that liquid rocket engines aren't the best way to get you around once you're on orbit. Now, we're still using that to take upper stages, third stages, second stages to take you to higher orbits and stuff, but that's not the most efficient way to go. And so they started to see this with...
So there are these regimes.
Yes.
There's acceleration regime, delta V regimes
Yep.
that don't call for the same solutions.
Correct. There's more solutions available than what we've typically used before.
Okay.
So the electric propulsion came on the scene a while back.
And tell me how that works.
So typically you're talking about a Hall thruster type system. So you're creating ions that you're accelerating out the back of an electric motor or engine.
Wasn't that an ion engine?
It's an ion engine.
Oh, okay.
Yes. It's all
Okay. Right. I thought something different, but it's not.
electric propulsion ion engines are in the same family. They're very efficient, but they don't have a lot of thrust.
Right.
So because you're not creating the acceleration, because you don't have a lot of thrust, you don't get anywhere very fast. So satellites said, okay, that's cool. If it takes us weeks or months to get to an orbit where we're selling electrons for broadband internet or TV or whatever, that's fine. But then our adversaries started developing spacecraft that could move a lot faster with higher thrust. And then they started doing things on orbit that threatened some of our critical infrastructure. And now we have no way to kind of maneuver around that.
So there's strategic value
Yes.
to this.
Maneuverability is a key ingredient of warfare on land, sea,
And
air,
space now.
and now space.
You think? So chemical rockets, we are removing energy that was built into the molecules that are in the fuel tank. That energy gets released. You expel mass out one end. The rocket recoils by going the opposite direction. Newton's laws.
Yep. Accelerate those particles in the thrust chamber as
With
fast
very
as possible.
high mass, high speed coming out the back. Once you are in place, you now kick out ions, which have very low mass, but high efficiency. And so it'll move you if you're patient.
Yes.
And so these are two different needs,
Yes.
clearly. Okay.
And now there's a new need, which is we don't have that patience any longer.
Right.
Got it.
Now, what are I'll say our adversaries? What are they using for maneuverability
Well, if
on
you look at what China's done, as they've grown the amount of mass they can throw with their Long March launch vehicles, they're just making bigger and bigger spacecraft with bigger and bigger tanks and bigger and bigger thrusters.
So they're brute forcing it.
Yes, sir.
Okay.
That's correct.
That's what they're doing.
And we like to be more elegant.
Yeah.
Remember my story about the Russian rocket
Right.
versus
Exactly.
American? We always want to think about everything.
Right.
As my wife often tells me, I'm in my head too much. That's very much an American.
But you know what?
That can
I
happen.
kind of feel like precision and elegance wins out in the long term if you can get past the short term.
And commercially, yes.
Yeah.
Because you need that elegance to hit a price point that's going to make you both commercially viable and viable for the defense industry
Right.
as well.
Yeah, and unlike America, they spend as much money as they want on anything that they want.
Well, and China's completely aligned in their military-industrial complex.
Right.
Yeah.
I mean, there's only one
There's one
chain of command
chain of
and
command.
one person that makes those
Right.
decisions.
Exactly. And that's what I want here. That kind of efficiency.
He channels Trump. He can't help
Donald J.
He
is
can't,
my
he
name.
can't help it. He can't help it.
I'm sorry.
So is there anything you could testify in Congress today that's reminiscent of what you testified back in 2015
That would let them
about
know
our
that-
needs,
and to
the
let them
transition
know
of our needs?
what kind of dumbasses they are. Because they are dumbasses.
So
I'm sorry. I'm sorry.
the interesting
We
thing,
can cut that out. Please don't cut that out.
the interesting thing about all of that is that when I testified before Congress in 2015, it was about, why are we sending all this money to Russia and buying their engines when we've got engineers we need to train in the United States and we have commercial companies that can do the job? And that was my argument. And I said, hey, Falcon 9, Falcon Heavy, Starship, Raptor are coming. It's going to be a thing. Fortunately, I was right on all of that. What I would say today to different committees before Congress is, our adversaries are coming for us, and we are cutting R&D spending, we're cutting engineering, we're cutting science, we're cutting all of the things we need to be competitive.
We're also spooking immigrants
Yes.
who could have expertise, as they've always had.
Yes.
I mean, when I was in graduate school, half of my fellow graduate students were foreign nationals. Half of them.
And
now they're all spooked because they don't know what's going to happen.
yeah, and China's made no bones about they want to be the preeminent superpower in the world. So I don't know why we kind of have our heads in the sand about this.
No, it's a head up our ass. Say it right.
Okay, sure, head up our ass.
That's
so
a darker place than in the sand.
If I was testifying before Congress to your question, I would be hitting those points really hard because we need to be accelerating capabilities that are going to preserve. I want to preserve low Earth orbit, mid Earth orbit, LEO, cislunar around the moon for commercial opportunities in the future. And so my thesis is, if I don't do my part to protect and defend it with the Department of Defense, there's not going to be a spot to make money commercially in the future. And that's how it's been. So we started sailing wooden ships. The pirates were there. It's going to be no different on orbit. So what are we going to do about it?
Yeah. And so let me describe what I think is going on in space, and you either say I've got it right or modify it as necessary. When people hear Space Force, they say, oh, there's going to be weapons and bombs in space. And it's not really what's happening there. What's happening there is our assets that enable what we think of as modern life and civilization are fundamentally pivoted on what we have orbiting this Earth, with the satellites, the GPS, especially our other communication satellites. And so if you have a military, it's not, oh, defend this border, take this hill. No, it's defend our assets. And our assets are bare-assed in space. And an adversary who wanted to take us out, blind us, they would go to our communication satellites and take us out.
Just like Independence Day.
It was Independence Day. You remembered that.
That's right.
The aliens came and took out all of our satellites.
Leave the World Behind on Netflix.
Oh, that's another one.
That's a great one.
Leave the World Behind.
Yes.
It was a tech warfare. It's not.
Do not watch that movie with Neil, by the way.
Oh, I think that'd be fun.
No.
No?
Leave the World Behind. That was actually, I think the Obamas were executive
Yeah, they
producers
were.
on that
That's
project.
correct.
A terrifying movie, actually.
It
Leave the
was.
World Behind.
But to your question to me,
Yeah, so would you agree with how I've
I
characterized it?
loved how you characterized it, because that's the same message that I try to send when I'm talking to, why should the average citizen care about this? They should care because when they go to the gas pump, it's not going to work because GPS does the timing for the gas pump. When they go to get cash from the ATM, it's not going to work because GPS does the timing for the ATM. We've selectively tied our financial systems to GPS, and we did that. We made a choice. We said, oh, this is cool. Let's do this. This is handy. China did not do that. They have other ways they do timing for their banking and financial assets.
My money's in my mattress, so it's not a problem for me.
And not just China, but other countries, right? So we made fundamental decisions with our space technology that have made us vulnerable, to your point, which is why people should care so much about this
And we
problem.
have battleships and Marines that could do 100 push-ups and launch silos, and any country that's smart is not going to attack us on those grounds.
Right.
It's going to find, you're just going to find a weakness. That's how any war unfolds.
Well, and guess what? All those assets up there right now, can they move when they're threatened? Can they defend themselves in any meaningful way? I would argue probably not.
And I also heard, and I haven't confirmed this, but I heard, and you would know, that some adversaries will have satellites that'll nestle up next to our satellites and just basically harass them, either with an electromagnetic field or something. And so we then have to move our satellite away from them to maintain operability, but that uses fuel that we otherwise need to station keep. And so that will reduce the lifespan of some of our satellites because of this. And no, did it fire a weapon at us? No. Did it destroy us? No. It's just
cyberbullied us.
Yeah.
This seems like a very reasonable hypothesis to me.
Yeah, I heard that, and
was very diplomatic.
It's another way to mess. So Space Force is not.
Jeff
let's
did
put
not
bombs in
answer that
space.
question.
Let's protect our assets.
Did you see what he just did there?
What he said?
He was just like, that seems like a very reasonable hypothesis, which is like, oh man, that's exactly what is happening.
I was trying to channel my inner Neil.
No, that was good. That was good. That's why I had to point it out. That was excellent.
So in your current capacity as CEO of, give me the full name again.
Portal Space Systems.
Portal Space Systems.
You'll have to ask me how about the name of the company at some point.
I'll ask it now. How'd you get Portal Space Systems?
I used to watch Rick and Morty with my daughter.
Excellent.
There it is.
And so half of the story is the portal gun from Rick and Morty, because that's what I used to watch with my daughter.
You know, Rick and Morty is just Back to the Future relationship all over again. It's Doc and Marty.
Yes, that's right.
Rick and Morty, Doc and Marty. And he's got the same kind of, hey, Morty, come on.
That's right, Marty.
We got to go.
It's the same. Yeah.
That's very cool.
So tell me what's the coolest thing you're working on in your company right now?
So Supernova has been like
Supernova.
the flagship.
You took one of my words.
Yes.
My people.
Well,
that's our word, just so you know.
I wanted to be close to your people.
Yeah.
But we kind of have a star theme with our products at the company.
You know I'm going to love that.
I knew you'd love that because I love Cosmos. So I mean, with supernova, it's about that rapid movement. And it's supernova because we're using concentrated solar energy, and we've innovated around a heat exchanger, so we don't have to combust any liquid propellants with our system. So like a nuclear...
But this is towards what end?
This is so I can carry twice as much fuel, and I have a thermal engine cycle where I'm not using combustion. So I can have fewer parts, more efficiency, higher thrust, and twice as much fuel because I'm not carrying an oxidizer, so I don't have to burn anything. And I really wanted to do nuclear thermal, but I can't buy a nuclear reactor at Lowe's, and there's not enough of them to buy right now. So
10 to 24 gigawatts. Gigawatts.
Yeah.
You can't get one of those at Lowe's?
I want
at Home Depot?
I joke about this all the time because the thermal engine is a lot like Mr. Fusion from the second Back to the Future movie, because we use ammonia as our propellant now, but we could use
Mr. Fusion was in the first.
Okay, yeah, at the end.
At the end,
yes.
Which get you to the second movie.
Get to the second. You're right.
Yes, get your movie. You don't just don't with me here.
I like this. I like this battle of the trivia. So the thermal engine's a lot like Mr. Fusion because we can use ammonia, which is our baseline fuel, because it's very storable on orbit, and we have a multi-year life of our spacecraft. But if I want to start moving out to Mars and I want to use methane, in the future I want to use hydrogen, I want to use other things, I can use other fuels in a thermal engine system.
Oh.
So this
has versatility.
It's versatility because I'm very much a live off the land kind of guy when it comes to space. If we're taking everything with us, we've failed as engineers.
That's so cool.
Could you tell NASA that that's what they should call it instead of in situ resource utilization?
Living off the land.
Let's from now on, NASA, are you watching?
LOTL, okay?
Living off the land.
There you go, NASA.
That is way more marketable than in situ resource utilization.
Yeah.
ISRU. That's a big branch of NASA.
Heads up, NASA.
Yeah.
We're coming for you.
There's a cool company down in Florida. I'll give them a shout out. They're called AdMen, and they are an additive manufacturing company.
Oh,
and
AdMen.
that's
cool.
what they.
Cool.
That's what they work with on all the space people that they work with.
Right, because if I'm going to Mars, I won't think of all the things I need to live, but I want a print machine that can print any tool I need once I'm there. But anyway, so with supernova, it's about propulsion, but it's about payload flexibility. So what that means is software definable power, which means you have a payload, you have a camera, you have a robot arm, you have whatever you want to do whatever mission. It's like a Lego brick onto the front of the payload deck. Perform your mission. I'm selling, I'll get you there as fast as you need to be, and I'll give you a platform that's very versatile over multiple years.
Not to stupidly simplify it, but are you saying you have a warehouse and I have a need, and I say I want to put this object on Mars and do some things, and you say, yeah, get two rockets from aisle A and 2 boosters from aisle B, and then we assemble what it is that will serve my needs?
Well, from a spacecraft standpoint, yes.
Okay.
So I am going to build you the spacecraft, and whatever you need on that spacecraft to perform a mission, whether that's a camera or a telescope or whatever, I can supply power and data to that.
That is engineering heaven right there.
That's wild.
Because that's one of the biggest problems with satellites right now is everything's bespoke. So you want to have a telecom satellite. Oh, I'm going to build the whole thing, including the telecom payload.
And that's
all
way
it does.
more expensive.
Yeah.
The one-off. It's a one-off.
And if your customers don't show up and want it, then your business fails. I can't predict everything the customer needs, so I didn't want to try. I just wanted to give them a spacecraft that could meet all their needs.
Wow.
Okay, so when are we having warp drives?
And when
Right now,
and how do we get in on the ground floor of your company?
Let's talk afterwards. Talk on the side. We can make that happen.
What's on our doorstep? What remains only in the dream states of engineers?
I think 2 things. If I was king of American engineering for a day, for space, I'd accelerate AI and machine learning and get more robots and AI out there doing the heavy lifting for us.
It's called Skynet. You realize
I get that, but I think you could. I think
we accelerate AI and make more robots.
And make more robots.
You need a different starting phrase.
But let me tell you why I said that. We spend so much time and money trying to keep humans alive that it slows our pace of exploration
Everything.
on orbit.
It slows everything.
So let's get AI and ML out there on spacecraft, exploring the solar system and teaching us what we don't know yet.
ML, machine learning.
Yes, machine learning. So that then we can engineer the systems that keep people alive and get it right the first time. And we can get more exploration done faster because we're not spending all this money to keep people alive right now. Let's go learn what we need to learn to keep people alive.
You better not name the robots because then people will feel for them. And if you don't bring them back, that meant you killed a robot.
I'm okay with that.
Yeah, I haven't made up my mind on that.
I'm just saying, there's a whole ethical frontier there about feelings for things that have
There's actually an ethical society that has come up around the treatment of robots.
I guess I would tell those people it's easier for me to keep your robot alive than a human alive in space.
That's
you got my vote with that one.
There you go.
And then on the propulsion side, I think what we're learning in quantum physics, this is where I'm going to carefully delve into your universe for a hot second. I am not the expert in quantum physics, but I do read a lot because I'm super interested in what we're learning there. But I think there's elements of the quantum world that are going to unlock propulsion technologies that might look similar to a warp drive, but I think we need to unlock some more understanding of the quantum universe to do that. I think that's going to be the linchpin in giving us sci-fi geeks the warp drive we want.
So a quantum FFRDC would be a cool thing.
That would be an awesome thing.
Right. It's just everything quantum.
And you could probably get that funded because there's a lot of defense applications for quantum as well.
God, yes.
Right. Okay, so give me an actual date where we're going to have a warp drive just so I can put that on my calendar. We know when the warp drive gets invented. It's 2063.
Correct.
In Star Trek.
Right.
So those are your marching orders.
Okay.
Okay.
I think we can do that.
You got 40 years.
We're moving fast in quantum.
It's via the quantum.
Via the quantum.
Okay.
I think that's our best path right now.
All right, because if you know, at least even in Back to the Future Part 2, they predicted that the Cubs would win the World Series.
And they did.
And they did. Yes.
Yeah. But even a broken clock is...
It's true. What did I say? A blind sow finds an acorn every once in a while.
There you go. Yeah.
But I think that with warp drive, it's not about this propulsive thing that we're all mentally geared to. It's how do we leverage quantum to manipulate the fabric of space-time?
So quantize gravity and things of that nature.
You have to you're going to have to figure out how to fold space-time.
You need a new understanding of the fabric of the space-time continuum.
Nice.
Manipulate that. It's not even about propulsion.
Propulsion, yeah.
That's right.
Right. Yeah.
That's Thornburg's theory anyway, for whatever that's worth.
Oh, okay. So, Jeff, we got to land this plane. But, Chuck, do you have any last questions for the man?
Yeah, I'm just interested, like, what would be the ultimate achievement in commercial space travel, or the holy grail? What is it that everybody wants?
I'm going to tell you what I want, and then we'll go to him.
Go ahead.
I want to go suborbital to between any 2 points on Earth, so that I'm no more than 45 minutes away from lunch in Tokyo, and then fly back.
Wow.
So that would require rockets, not planes.
Yeah.
Because orbit is 90 minutes.
Right.
So if you're suborbital, and half of that, you just go the other way. You can go anywhere in the world. And I think about that every time I go to Washington. I go to Washington like for a lunch meeting and then come back and I'm home for dinner. And if you told that to our founding fathers, get the horse ready.
Right.
Martha,
that would be an impossibility.
Yeah, they can't even
be
think
like
that way. So
thing.
pick that up. What awaits us?
For me, my holy grail is that humans can go to any orbit between here and the moon or the moon. It isn't a significant emotional event. It's just a standard
Going
way
to the
of
moon,
life.
I'll see you on Tuesday.
Exactly. That's wild.
That's what you want.
That's what I want.
So
in my lifetime,
cislunar space becomes our backyard, not even worthy of comment.
Correct.
Look at that. That's very cool. It's like saying, I'm going to Poughkeepsie. I'm going to the moon. It's all the same.
It's all the same.
All the same.
That's a worthy goal. I like that. So let me perhaps offer a cosmic perspective on this. I'm a scientist. I think sciencey things about the world. And at no time am I asking, how would one accomplish this? How would one build it? How would one pay for it? How much ingenuity does it require? Do I have to invent something that has never before existed just to solve the problem I have posed. I don't really have to think about that. And we have this community of engineers that walk among us who live for that. They live for it. You know what else they live for? Constraints on what it is they need to do. That was the most impressive feature of how engineers function. The last thing an engineer wants to hear is, here, go build this. There's no time frame, there's no money limit, and there's no constraints. They're gonna be staring at their navel to not knowing what to do. But if I say, I got 3 months, I got $2 million, these are the specs, and this is the requirements, go. Their ingenuity derives from figuring stuff out within those constraints. That's how we make discoveries, not scientific discoveries about how stuff works around us that so many of us, myself included, take for granted. So, there is no future of civilization without happy engineers. Engineers that are given problems to solve. And maybe it's up to the rest of us to give them the kinds of problems we need solved. Energy, housing, climate. Scientists can't solve those problems. We can characterize them, but we need engineers to step in the ring. And this is an appeal, I suppose, to a few. Not everyone can be an engineer. We don't want that. Engineers don't even want that. But engineers as a demographic of society that'll lead us into the future, there is no civilization without them. And for me, that is a cosmic perspective. Chuck, thanks for being here.
Always a pleasure.
And Jeff Thornburg, thanks for being on StarTalk.
My pleasure.
Coming all this way for us.
Absolutely.
This has been another installment of StarTalk. Neil deGrasse Tyson, your personal astrophysicist, bidding you to keep looking up.